So welcome back again in the series of learning flip-flops. Flip-flop is a single bit memory element which stores one bit information. So till now we have covered this SR flip-flop, then D flip-flop, then JK flip-flop, and in JK flip-flop we come to know that when J is equal to 1, K is equal to 1, so Q T plus 1 is equal to complement of previous output. So complement of say previous output. Okay. So this is the thing. But here, what issue comes? Let me try to explain here. The condition is known as race around condition. Race around condition. So let us see first. This is the diagram where you can see this is the circuit diagram, and this is the functional table where the past output is this one, or say present output Qt, J, and K. These are the three inputs. Then one is the output, that is Qt plus 1. Next state is the output, and for all three variable or 3-bit combinations is started from 000 to 111. All combinations we have written this side, and the corresponding output is written here. If we see this carefully, so this is the condition here, J and K both are 11. So next output is here, is complement of the present output. The present output is 0, so next output is 1. Again here, when J and K both are 1, and the present output is 1, so next output is the complement of present output. So this is 1, so it becomes 0. So this is the observation. But what is this race around condition and what problem it creates? So let us try to understand that. That is called race around condition. So here you can see we have to get the next output, that is Qt plus 1, a signal has to pass through two series NAND gate, that is 1, 3 or 2, 4, because these are in parallel. So signal has to cross these two levels of NAND gate. Okay, this is one thing, please keep it in mind. And now, and this is further triggered by this clock pulse, that is called a clock pulse. And when we know this state changes, state of this flip-flop changes when there is a triggering of the clock pulse. So please try to understand the signal has to pass through these two NAND gates, 1 and 3 or 4 or 5, and this clock pulse is responsible for triggering the output. Now let us draw the clock pulse, a typical clock pulse animation. A train of clock pulse like this. So it is symmetrical. Suppose duty cycle is 50%. So the time from here to here is called period. So this is a T time period of this clock pulse. So this is say logic 1 and this is logic 0. This is 1, this is 2. So assume that the time this one is same here. Okay. So from starting from here and from here, the time taken by this one cycle of clock pulse is here T. So this is the time period. And as we are telling that every transition takes place on this positives or level, positive level, not this logic 0. So triggering takes place for this region only. So for this region, triggering takes place, output changes. And suppose this is your TP. TP time period for triggering. And here this is TP. Yeah, TP. And let us assume that the time taken by NAND gates, 2 series NAND gate to give the output as delta T. What is delta T? Delta T is the time taken by signal to reach from this point to this point. And you can see the signal has to pass through these two NAND gates connected in series. And each NAND gate takes some time. The time, and since we design our circuit to work fast, okay, it should take lesser time. So computation time should be very, very less. So the device should be faster. So this is what we are trying to tell here, that the time taken by a signal traveling from input to output is TP. Now this is the background. Now let us see this J and K. When J and K both are 1, 1, J is equal to 1, K is equal to 1. So Qt plus 1 is equal to Qt bar. That we have seen at this condition. That we have seen. Let us revise. J and K both are 1, 1 and this and this. And output we can see here is the complement of the previous one. Next output is the complement of the present output. So if it is 0, then it is 1. If the present output is 1, the next output is 0. This is what we are trying to say here. So what happened when J and K both are 1, 1, and as per truth table, next output is complement of the previous one. And suppose Qt is 1, for here Qt is 1, or suppose 0. Qt is equal to 0 for the first case. This case, this one, third number case. Now, what happened? If J and K is equal to 1, clock pulse has come. This much clock pulse has come. And next output will be from Qt is equal to 0 to Qt plus 1 is equal to 1, because this is the complement. But we see, even if you do not change anything, means J and K is equal to 1, and still clock pulse is coming. See, duration of clock pulse TP is greater than the delta T. This TP is greater than delta T. So what will happen? The circuit is still being triggered by the clock pulse. So what will happen? Then again the same situation. Since we have not changed any input state, so J and K is equal to 1. So Qt plus 1 will be what? Qt plus 1 will be, because present output is now 1, next output will be 0. So what is going on? For only one clock pulse, you can observe that the output is toggling. Output is changing from 0, 1, 1, 0. So this is not a kind of stable, it is kind of blinking. 0, 1, 1, 0. At which case, the case when J and K is equal to 1, and this start, clock pulse is coming, and then your output is Qt 0, 1, 0, 1. The 2 times output has given. This should have the stable output, which is not the case for other combinations. Okay. So this is called race around condition in JK flip-flop. So this is a problem. So how to solve it? So we can solve if this delta T should be greater than or is equal to TP, but less than equal to T. So we have to increase this. How can we increase? See, on one hand, we want to fabricate a device which is faster, which should do faster propagation without delay, high computation speed. But on the other hand, we want to hear, no, our output should be delayed, means it should take time, at least TP. So without compromising the speed, what is the remedy? of overcoming this race around condition is called master slave JK flip flop. Master slave JK flip flop. Okay, so operation will be same. Only we will increase this time to get the same output. Okay, output will be complement of the previous one, but it should be stable. It should not blink between 0 and 1. So how can we make this master slave JK flip flop? So I am going to draw the circuit of the same master slave JK flip flop. So here let us write master slave JK flip flop. So I will draw here circuit starting from the basic cross coupled NAND gate. This is input, and this is here. So again, one more. So this is what we are drawing to now. This is PT bar, this is PT. Now we have to connect it together. Then it is here. This is here. So this is called a slave side of circuit. So this is my slave portion and this is here master portion of JK flip flop. So feedback is from here, and now this is clock, and here the clock pulse but inverted one. So this is clock, and here the input J and K, and this is the output. So you can see compared to earlier section, now master slave is nothing but, if I draw a block diagram, so this is a JK flip flop, this is again a JK flip flop. Output of this is connected to input of this, output of this connected to input of this. Only the triggering is done here through NOT gate. So this is J and this is K, this is clock pulse, and here output T bar. So this is a detailed diagram. Here this is a block diagram. So up to here you can see, up to here this is master portion here, and from here to this side is slave portion of this flip flop. So this is master and this is slave. So in this way, see, now input which is J and K as well as clock. So J and K, this the signal from the input to output has to travel now 4 NAND gates. Suppose 1, 2, 3, 4, which are cascaded. So we are increasing the total propagation delay time taken by the signal to reach the output. Similarly for K. However, this function will when master is working, suppose this clock pulse is 1, then it is being the output. At that time you can see the when clock is 1, but clock for slave is 0. So it means slave is not working when master is working. So when master is working, output gain, slave is not working. But when clock pulse is 0, this one, then it will be 1, and then accordingly it will transfer the input to the output. So through this way we are able to increase the propagation delay time of input to output, and hence that race around condition is overcome. So this is the problem which was there in JK flip flop simply, that is when J and K both are 1, 1, and the output is completely a previous one, then there is a toggling kind of situation. Okay, that we have seen from this timing diagram. Now this can be solved by increasing this delta t. How? Because up to here only master was working, till here slave is working, where 0 is there. So in this way, we are able to solve this issue. Okay, so we will soon meet in next class. Thank you so much.